So similar figures. I've got a couple of groups of them here. They're the same shape, but not necessarily the same size. So you can just kind of see these figures are all the same shape, but different sizes. These two have the same shape. These three have the same shape. These two have the same shape. And to be more technical about it, similar figures have proportional corresponding sides and congruent corresponding angles. So to show you what that means here, let's say that the length of this side is 8 and this side is 4, and this side is 4. Let's make that 2 actually. 2 and this is 1. So let's call this side A and this side B. Oops. Let's call it A1 and B1. So the corresponding sides would be A2. Let's call that, and B2. So the ratio of A1 to B1 is 8 to 4. And that's proportional to the ratio of A2 to B2, 2 to 1. And proportional meaning if you reduce everything, they'll have the same value. So is 8 over 4 the same as 2 over 1? Yeah, you could divide both these guys by 4. You could take a 4 out of these. 8 divided by 4 is 2. 4 divided by 4 is 1. 2 over 1 equals 2 over 1. Yes. You can also look at it as the ratio between B1 to B2 is proportional to the relationship of ratio of A1 to A2. So for example, B1 to B2 would be the ratio of 4 to 1, and the ratio of A1 to A2 is 8 to 2. Are these proportional? Do they basically mean the same thing? This is as reduced as it gets, but you could take a 2 out of both these guys. Messing up my pretty teardrops here. I was kind of proud of those. 8 divided by 2 is 4. 2 divided by 2 is 1. So yeah, same thing. And okay, so they have proportional corresponding sides and congruent corresponding angles. So if this is angle 1, that's 90 degrees, then the corresponding angle 1 would be 90 degrees, something like that. And it gets, I don't know, a little bit more interesting with triangles. Here I have 3 similar triangles. These are rotated, so don't be fooled. If this is side A here, then this is side A there. And if that's hard to see, actually I'll just show you if you just kind of rotate this in your mind, you know, these will line up. Those sides definitely correspond. So similar figures don't have to be pointed in the same direction. They just have to have proportional corresponding sides and congruent corresponding angles. So if this is side A and that's side A, this is side B, side B, side C, side C. If this angle is 90 degrees, then this angle has to be 90 degrees. If this is, I don't know, 45 degrees, which it's not, I don't know, say 30, then that would be 30. Something like that. Actually, that's probably 60 and that's 30. Anyway, it doesn't matter. The corresponding angles would have to be congruent or equal. And that's what makes these have the same shape but not the same size. So here's some other similar figures. The proportional corresponding size bits gets a little more complicated with weird shapes like teardrops, but this is kind of just a visualization of it having the same shape but different sizes. And then, you know, when you get into rectangles and triangles, you can actually measure the proportions between the sides and prove that they are similar.